All right, back to our law of cosines word problems. Problem number 7, Lee hears the 4 p.m. whistle from Archer Industries 20 seconds after 4 p.m., which means he is far enough away that there is a delay in the sound. Okay. And the whistle from Gomez Manufacturing 40 seconds after 4 p.m. The angle between Lee's line of sight to the two buildings is 50 degrees, and sound travels at approximately 0.340 kilometers per second. How far apart are the two buildings? So basic idea here, we've got Lee, who is standing somewhere. Somewhere over here, let's say we've got Archer Industries. And 52 degrees somewhere else, we have Gomez Manufacturing. So this angle is 52 degrees. And Lee is far enough away from Archer Industries that there is a 20-second time delay. And from Gomez, there is a 40-second time delay. So if it takes 20 seconds and sound travels 0.03 point say it right, 0.340. All right, so from Lee to Archer Industries is 6.8 kilometers, and it's 40 seconds times the same rate, so it's going to be 13.6 kilometers. And we want to know how far apart these two buildings are. So we want to know that distance. So same law of cosines we've been setting up. X squared equals 6.8 squared plus 13.6 squared minus 2 times 6.8 times 13.6 cosine of 52. All right, everything into the calculator. Again, I'm going to keep saying this. Make sure your calculator is in degree mode. If you're ever unsure, ask. All right, check out, find out, what you can do to make sure your calculator is in degree mode, or if you're using Desmos, how to check Desmos. That's not something I'm going to, hide from you guys at all. So take the square root of that answer of 117. So x is equal to 10.83. We know this is in kilometers because we were told that sound travels at kilometers per second. So our units for distance are kilometers. So the two buildings are approximately 10.83 kilometers apart. All right, problem number 8. The sides of a triangle are 4, 6, and 8. Let's go ahead and draw that. 4, 6, 8. If theta is the smallest angle of the triangle, well, smallest side is opposite the smallest angle. So this would be theta. What is the exact value of tangent of theta? Now, this is going to be a little bit weird because we don't have a law of tangents. And that's okay. So we need to work with what we can do, which is law of cosine. So we're going to go ahead and set up law of cosines. So 4 squared equals, and don't change anything about it, even though we're looking for a tangent answer. So it's still cosine of theta, all right? That's going to stay. It's all right. And we want to solve for cosine of theta. So I'm going to zoom in just a touch on this. So I'm going to subtract 6 squared and 8 squared from both sides. So 4 squared minus 6 squared minus 8 squared is negative 84. And then I'm going to multiply this out. So negative 2 times 8 times 6. Hold on one second. Calculator's yelling at me. Too many buttons to hit. Okay, there we go. So negative 96 cosine of theta. I'm going to divide both sides by negative 96. And like we did in one of the earlier problems, I am not going to use the decimal answer for that. I want to get the fractional answer simplified, and my calculator will do that for me. So this is 7 over 8. that is right now, that's the exact value of cosine of theta. Now, I don't want the exact value of cosine of theta. I want the exact value of tangent of theta. So what I'm going to actually do is reset to a right triangle. And I'm going to label theta in a corner. Now, cosine, I remember, is adjacent over hypotenuse. So the adjacent side 7, hypotenuse is 8. I'm going to use Pythagorean Theorem to find that unknown side. I'm going to call it A. All right. So Pythagorean Theorem says a squared plus 7 squared is equal to the hypotenuse squared. So if I do 8 squared minus 7 squared, that's 15. So A is equal to the square root of 15. All right, so square root of 15. Now, what I'm looking for is, again, I'm going to remind myself, I want the tangent of theta. Well, now that I have the right triangle, I can say that the tangent of theta is the opposite over the adjacent. So root 15 over 7. And that is the exact value. And yes, it might look weird. It's, you have a square root and a fraction. That's okay. It's the exact mathematical value. So let it be what it is. All right, I'm going to go ahead and close this video out. I'll make one more video for the last 2 problems,